Hey everybody, so today we are talking about absolute value inequalities that have a less than sign. So I want you to remember that the absolute value of a number is that number's distance from 0 on the number line. For example, if I have the absolute value of x is less than 4, I am talking about anywhere where you could pick a number and its absolute value would be less than or equal to 4. So let's talk about equal to 4 for a minute. That would be -4. Trying to color in that dot. And +4. Both of those have a distance of 4 from 0. But if I'm talking about all the numbers who have that distance or less, it would be everything in between here. So anything between -4 and 4. So if you've watched the video and done some practice on compound inequalities, then you know that we could write this graph as a compound inequality. So for example, I would have x, sorry that was terrible, x could be anything greater than or equal to -4, or less than or equal to +4. In other words, x is in between -4 and 4. Okay, anytime you see a less than sign, I want you to think less than and greater or. Okay, we're not going to talk about greater or greater than signs today. We'll do that in another video. Because you cannot write the greater than or the or statements as compound inequalities. It's only the less than statements that you can write as compound inequalities. So I'll give you another example of how this works. So let's say the absolute value of x is less than 5. Okay, so on a number line, that could be anything in between -5 and 5. Alright, now we're not going to include that, so I'll do open circles because it can't be -5 or 5, but it can be anything from -5 to 5. So as a compound inequality, we would say, one way to write that is to say that x is in between -5 and 5. In other words, -5 is less than x is less than 5. Being able to translate from an absolute value inequality to a compound inequality is going to be key to solving and graphing these things. So a lot of times we have some solving to do first before we can go ahead and write that. So here are the steps. Step 1 is to isolate the absolute value. So we will we'll do that. What I'm talking about is whatever's inside the absolute value bars, we want to get that by itself in our inequality. So for this one, we'll just subtract 3 from both sides. We get the absolute value of 6n is less than or equal to 18. Okay, so now that that part's by itself, we have step 2. Because it's less than, we can rewrite it as a compound inequality. So I want you to just kind of write what you see. So 6n is less than or equal to 18. Kind of get rid of the absolute value. Then on the other side of that, keep the inequality sign going the same way, and we're going to make that -18 on this side. Alright, then we need to solve that compound inequality, so I'll just divide each part of this inequality by 6, and I get -3 is less than or equal to n is less than or equal to 3. On a graph, that is everything in between -3 and 3, including -3 and 3. Okay, let's look at one more. Okay, on this one, same steps. I want to isolate this part. So I'm going to start by adding 10 to both sides. Just to save space, I'm not going to write out each part. So we have the absolute value, or 9 times the absolute value of n minus 8. Is less than 36. Divide both sides by 9. That gives us the absolute value of n minus 8 is less than 4. Now I have that absolute value isolated, and I can go ahead and write it as a compound inequality because it's less than. If it's not less than, you can't write it this way. But since it's less than, we'll go ahead and say negative 4 is less than n minus 8 is less than 4. So we will add 8 to all the sides, and that gives us positive 4 is less than n is less than 12. So those numbers don't have to be the same, they can be different. So this would be everything from 4 to 12.